Good evening, everyone. Today I'm presenting the proposal. This proposal is like short. Some maybe information is missing due to a slight misunderstanding about today. So, so today my topic will be on the RM. So here will the outline, introduction, device fabrication, result and discussion, and future work. So here we'll go with the first, the introduction about non-volatile and volatile memory. So here we can see the two types of memory which work. One is a volatile, one is a non-volatile. Volatile is require the power to retain the data, and non-volatile, even if the power is turned up, the device can retain the data safely. So introduction of the background of the RM is device structure, how the device work and what structure is only used in recent. So here we'll go with the, it's called MIM structure, metal insulator, metal. So then we did the two terminal, like one metal and two terminal metal, and there will be the insulator which can turn and off the device. There is a transition metal, like you can see. Then we apply the bias to between the device from high to low resistance and low to high resistance to make on and off. The metal changes in state, and then the made by the tungsten metal and peroxide organic material. The top electrode mainly have to use the nickel TiPT Ag4 several. So here we'll introduce of the RM or switching operating process. So this is the like initial state of the memory. We can see there is no any bias, so like it's also it's called. Then we apply the first to threshold, like choose the initial to low resistance the device. So we apply the forming voltage. It's called the light. It's a breakdown the device. Then we apply to turn from low to high resistance breakdown the device to make lower to higher. Then here is again we apply positive bias to turn the device from high to low. So it's can repeatable to multiple times. Then we can know the duration of our device capability. So here also we know the device how it's work with the oxygen ions migration. So you can see that's the first of the initial device. We have is a no oxygen vacancy. Then we apply the like fires to form the oxygen vacancy to create a filament from the lower high resistance to low resistance. It's called forming. Then we apply the negative bias to low to higher, so where we can see the like filaments is going back to the top electrode, and then we apply to break the filament oxygen vacancy back to the bottom electrode. It's called reset, and then again we repeat to form. It's like a form, it's like a set. So then it can repeat of multiple, like as I previously say, how it work. Then there is the three types of model for memory. First, you can see this, the polar will work in one polar, like positive on and positive off, or negative off and on. And this is called bias. So bilayer means it needs like negative and positive bias to turn and off device. This is called unipolar. Unipolar is like device can work two terminal, like also positive, also negative. In positive set, positive reset, negative set, and negative reset. So it's called unipolar. This is the model is like homogeneous. You cannot create by ourselves. It's like a naturally is happen to device, or you can operate by applying the bias. So next I will show my structure where I have optimized. So here we'll see the my structure how I fabrication process. So like bottom electrode is a tungsten nitride is deposited by the spotter with 180 nanometer memory, and memory layer is like a silicon and TX. So there I fabricate the bilayer device with silicon oxide and tungsten oxide. So both this switching layer is deposited by RF sputtering, and then I use as to form the electrode, to pattern the electrode. So I use the set of metal mass by, and then I deposit the top electrode, is the ITO, with the sputtering. So later I study for this device for radiation effect. So like we go to the radiation with like accumulate 1, 2, and 5 mRad, the rate of 0.72 farad per hour. So here with the same structure, I have the 3 devices. So 3 devices with same structure, same optimize, same everything, but I fabricate 3 devices, the same. So here I call the device A, B, C. So like A is the device where I accumulate the radiation with varying first 1 mRad, 2 mRad, and 4 mRad. And then second, the device B is constant, keep in the chamber to accumulate until 4 mRad. And the third is the pristine. So I will first explain what is the reason I put and how is the experiment for device A. So here, like we can see the experiment of device A. Like first, the device is the pristine, where I just measure the sweeping voltage 0.1 is called read disturb. Read disturb. So where I took the 5 device with 200 and 100 micrometer dimension, and there I just apply the initial device to check stress. It's called read disturb. So I will show the next slide, like how it did. So here, and then like you can see the rate, and the next after the pristine I take low and high resistance, the read current. The next I put the device to the radiation chamber to accumulate 1 mRad, and then I take back to the measurement, and then I repeat to take the read disturb with 1 mRad. What is the variation in the resistance? So then I put back again. I took 2 mRad, then I did the 4, and until after accumulate the 4 mRad, then we did the switching. Before that, we didn't use the device.
Wait,
it is
presentation stature.
more.
Do you always crouch when you present?
Oh.
Yes.
Okay.
Do you need your fingers on the keyboard every time?
No. Okay. So here, after 4 mRad accumulate, we use the device to check set and reset. So next here, the device, how we did the measurement. So like where you can see the figure, the left-hand side, there is the different read disturb. It's called read disturb. Like we every like after accumulate the every radiation, we did the read test, so we can see how the variation between device to device. So this after see this variation, we think to go for like interface, say, implement radiation. This is the call like accuracy between how the conductance is vary from the resistance to resistance. So it can be like neural network computing. So like neural network computing, we need the precise the device how is conducting time by time. So we did on the radiation and to check like how is going the conductance by different radiation. So this is the IV curve with my device with pristine and post radiation. So here is a like previous I explained. There's a 3 types of device A and B, C. Like so here is the pristine where you can see the pristine have the set voltage 3.45 and the reset voltage is the 4. So but after the radiate the device, we saw the slightly the voltage is decreases is due to the like introduce the oxygen vacancy increase after after radiation. So after radiation, like oxygen vacancy is increased. So oxygen vacancies mainly help to device use really easily and also turn off easily. So there will no require like a large voltage. And then we run each device, like one device we run for 100 cycles to check how the device stability. So we can see the pristine device is the black, the low and high resistance is around 1 ratio. And also we can see the after write accumulate 400, the device have the little variation in the resistance, but we did the device with like multiple like 1 to 4 emerald. So device have showing the large variation of the window ratio between 2 times. Then we did the retention. With the retention mainly we do with check the device can retain until how long it can be volatile. So we just check for 1,000 seconds with the pristine and post-radiate device. The mainly we can see there is a not large variation in the device. So this result after we targeting to submit in the conference. So where the conference is going to be like in Japan is called SSTM. So SSTM is a mainly of the solid state electron device material. So in this device there is a number 2. Our is meeting our application, like I work on the emerging memories. So there is a topic, so I have chance to submit this paper. So deadline is my first. So it's a very short time. So like I almost prepare the draft. I have to modify, and there is also the other groups have chance to submit if you like to. So you can also submit the late news. So late news, if you submit, so there will be no chance to have a registration for your journal publication, but you can attend your oral defense or presentation or poster presentation. You can do. So next, there is a second my device with the radiation is called hafnium-based radiation sensor. So here is my purpose to forget this device to investigate about the sensor, like radiation sensor, how it is accumulated. So here we did with the different, this is the different group fabricate this device. So you can see the green is the dimension die of the size is 60 micrometer. So here we go through with the 2 radiation dose. One is the 50 carat and one is 5 emerald to check how the voltage is vary from different doses. So I have just for confirming, I have put one slide for IV curve. There is a lot of measurement, different type of, but I just for presenting in this group, I just put one IV curve to show. So we can see the pristine device, the IV curve is showing the voltage around 5.5. But when we apply the
Okay, I'll stop you. I think you have used much time. Can you go to split notes? How many slides do you have remaining?
just few, just
Okay,
last 2.
no,
Last.
Go to split notes. Hiding notification.
Okay. After notification, hide is account.
Right. 3 slides in a row.
Okay.
Make it larger, please. Okay, good. No, that's too much. Move up a little bit. Right, so as I told you, if you're expecting your defense to come within a few months, your proposal is like a rehearsal for your defense. So you need a title.
Yeah.
Like what's the title?
The title I haven't decided yet, but
Yeah, so that's the issue. Yeah. So if you don't have a title, even in the a tentative title, that's something you need to worry about. Right? You don't have a direction, you have a title, then how can you make a defense?
Actually, I can say the title, but I didn't put.
Okay, what's the title?
The title will be the reliability of the metal oxide based radial for neuromorphic hydrogen.
Wait, say that again. Okay.
Reliability metal oxide based neuromorphic.
Reliability. What?
Yeah, reliability based. Reliability metal oxide. Reliability
metal oxide.
Yeah, metal oxide base.
I don't think that grammatically makes sense.
Because the metal oxide, why?
No, it grammatically doesn't make sense. Do you say reliability of or reliability? What? Reliability metal oxide?
No, reliability of metal.
Okay, say it again precisely.
Reliability of. Or maybe I will try to.
Then you don't have the title. You just said with confidence you have the title, but now you don't have it.
Actually, I wrote, so I will think of it. It will be on the metal oxide base because.
Okay, then it's about RM. Then why are we talking about sensors?
Because there will be also sensor.
Then
so
because it doesn't fit your title.
Because the metal oxide, there will be the metal. That's why I didn't put the RM, the metal oxide, because there will be.
Then your title is metal oxide what? Reliability of metal oxide what?
Base like.
Metal oxide based what? Stuff.
Because there will be still like a neuromorphic and also sensor. So I will combine for like a space application, something like that.
And to me, that doesn't make sense. You have to make it. You need to make it make sense.
Okay.
So far, it doesn't make sense. You talk about RM. All your introduction material is about RM.
Yeah.
And then you talk about sensors. Doesn't fit. Doesn't work. Your introduction is about RM, and then you talk about sensors. Right? And did you mention what sensors are?
I said the radiation sensor.
Yeah. How does it work? Does it have to be metal oxide? I think there are various forms of sensors. So what's the uniqueness? What are the advantages provided by using metal oxide-based sensor? You don't have that.
Yeah,
sensors is an entirely new field. You need an entire introductory chapter on it. Yeah. Without it, it makes no sense. Okay. So that's why I stopped you. The moment you went to sensor, I said, this is no good. You cannot do that. Right. All right, let's start from the beginning with your introduction. That part is relatively okay with some minor flaws. For example, let's scroll down a little bit. Let's look at slide 7. Okay, since you said you are expecting your defense, I'm going to be picky. All right, can you tell me why unipolar, the bullet point, unipolar, it's not aligned with bipolar? Is bipolar within the unipolar category?
You mean the line?
No, on the left, or the text.
Yeah.
You see the bullet points for unipolar.
Yeah.
It's not aligned with the bullet point for bipolar.
Yeah.
So it seems unipolar is on the upper level than bipolar.
Little here, shift.
Now this is a small thing, but it's confusing.
Yeah.
Right? They should be, 3 separate items, right? Unipolar, bipolar, and bipolar. They should be on the same level. Same level.
Same level, yeah.
But your method, your presentation here doesn't make it happen.
Yeah.
Right? That's a small issue. And I don't recall you explaining compliance current and resistance ratio when you're making the presentation. Is there a reason you skip this? You put it there, you talk about it. If you don't talk about it, erase them. Yeah. Let's look at slide number 8. This next slide. Okay. You'll notice that there's a large gap between slide number 7 and 8. Slide number 7, before slide 7 includes section before slide number 7, that's the intro, that's the background, right? Yeah. The background for RM. Okay. Now, As you move to slide number 8, you notice no one will understand what this is. Is this a survey? Is this your work?
Yes, my work.
How do they know? Okay, and if this is your work, what is the motivation? Why are you doing this? Why are you using tandem oxide with silicon oxide? You said this is bilayer, right? Why are you using bilayer? Why are you testing it with radiation?
Yeah, that is information is missing.
It has been missing for, I would say, for a whole year. Not once in your presentation for the whole year have you made such info clear. Am I right? Every time you made a proposal meeting, I reminded you that this part is missing. Well, that's a key point to have a structured presentation, right? You have to set up. You need to set up to make your experiment, to make your work valuable. Without it, it's confusing, it's valueless. If you talk about why the value of testing radiation affects the devices, then people see no point.
Yeah, that's true.
All right, and other stuff. Here you talk about a lot of these parameters with fabrication. Is this optimized?
Yeah.
Okay, do you have any proof that this is optimized?
Proof that I saw that is working. And
No, that's not optimized. By optimization, we often refer to changing a lot of the fabrication parameters, the gas flow, temperature. That's optimization.
Okay.
Yeah. So you don't have an optimized device. So you cannot say this device is optimized. This is a random fabrication process. You pick the numbers random. This might be your weak point, because if the reviewer asks, have you optimized this device? The only answer you can give would be no. And then the reviewer might ask you, then how can you be sure this provides the best performance? How can you show that any reliability issue you observe will also be present in optimized device? This is your weak point. Right, your device is optimized. All right, let's look at slide number 9. All right, A, B, C. This is the only time I see A, B, and C.
Yeah.
Right. What's the point of naming them A, B, and C if you're not using A, B, and C? For example, slide. Let's look at slide number 11. This is A.
Yeah, A.
How do I know? Slide number 10. Is that A?
Yeah, I put for A that.
Okay, it's slide number 11. That is A. Then slide number 12. Is this also A?
No, is A, B, C both. Like there is a 3 devices.
How do we know?
Because I say the pristine and post and fresh device.
So you expect your audience to figure out themselves. If you expect your audience to figure out themselves, then there's no point in labeling A, B, and C, right? The purpose of labeling your experiment, putting labels on your experiment setup, is to make it easier for your audience to understand what you're showing. Right, from what you're doing here, you can basically just remove A, B, and C. It doesn't really affect your whole presentation because it's just still as confusing. Right? All right, let's look at, let's go to split mode. So that's another main issue regarding your experimental section. Scroll down, please. Oh yeah, and slide number 11, the figure on the right, it wasn't explained and very low resolution. I still don't, I'm not entirely sure if you fully understand inference accuracy yet. Right, the resolution is bad.
Yeah, actually, this resolution is bad because I got from other groups, so they give me that.
Is that a reason you expect people to think?
No, I tried to enlarge the.
No, that's how it works. You enlarge it, it's gonna look like crap. The best way to do it is to get it from the source. If you really need to show it, get it from the source. Ask them for a lot larger one with good resolution. But this is sloppy. But you understand, this is sloppy, and you didn't talk about it. What's inference accuracy?
The inference accuracy is.
No, I'm not asking you to explain now.
I explained that.
I'm telling you, you lack the proper explanation. You think explain, but it's not enough. What's inference? How is it done? It's not that simple. It's not something you can explain with just this figure. Okay, and what's the embedded figure? The one that shows, I think, the current and what? Current cannot be it.
I think.
If you think, right? You think. What's the y-axis of the embedded figure? It's your presentation. What's on the y-axis? If even you cannot read it, then as a presenter you cannot read it, then how do you expect your audience to understand what I'm talking about? So you think you did some explanation, but in fact you didn't. Okay, that's another thing to be improved. Right, let's head back to the split. Hide the notification. Yeah. Right. All right, scroll down. So your external setup is not properly done. Let's go back down a bit. Right. This is not the best time for talking about your conference. This is more like a study session thing. Here, proposal you need to talk about full story. Slide number 14 doesn't give you any story. That's what you want to do. You talk about it when you're doing your study session presentation.
But it's like proposing what I'm going to do.
In terms of research, not about conference. At least, especially at this stage, this is a rehearsal for your defense. Are you going to talk about which conference you're going in your defense? No. So that's the logic. Anything that shouldn't appear in your defense has no place here. If it's your first year as a master, you want to talk about conference, yes, good. I love that you're motivated. But you're not in the first year of master. You're closer to your defense. So slide number 14 doesn't belong here. Let's look at slide number 15 with the sensor. I'm not saying this is bad work, but you have to make a good story. This doesn't line up with your previous work. You don't have to enlarge this. Slide number 15 and so on with the work with the sensor. Depending on your title, this may not be fitting to be included in a completely different field. In your defense presentation, it's not necessary to talk about all your publications. Unless they are related.
Okay.
So when you think about your title, try to think about how you can connect them. If you cannot, then drop it. Now, if you really want to talk about hafnium oxide-based radiation system, blah, 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 you've done a poor job. As I said, what are sensors? How does it work? Okay, and most of all, did you fabricate these samples? No.
Yeah.
Okay. What's your contribution to this?
This contribution to like measure to the radiation, all like things.
Yeah, so that's something you need to proactively explain. And slide number 16, between 15 and 16, is confusing. So you did some measurement, okay, then you jump to slide number 16. What does each curve represent? You show a curve without any labels, any text, any explanation. This is what we call overwhelming data. When you show 6 graphs at the same time, people's eye will move around from the first graph to the second one to the third one. Their eyes will be busy. When their eyes are busy, they're not listening. And for the next 10 seconds, they don't care about your existence. So this is not a good way of making presentation when you show a lot of things at the same time. 6 graphs, or actually 12, you actually have an inset. So a better thing to do, you can split up into 3 slides or even 6 slides. On each slide, you show just 1 graph with text, with a little label, key messages. Or you can try to combine them in any way. Use some creativity, use your head. Don't basically put 6 figures on the same slide without anything else. And then expect your audience to follow you. It doesn't really work. All right, that's all I have to say for this. And just remind you, you also need to prepare a lot of things. You need to prepare for your seminar presentation.
Yeah.
Right. And then you also need to, you told me you're gonna write the manuscript for the censor.
No, yeah, censor, yeah.
Yeah. And then you also wish to continue with the titanium oxide. We haven't got into the part with the data yet. So if you really want to make it to the conference in Nagoya, you'll have limited time. You only have 3 days.
Yeah.
Just 3 days.
4 days.
Do you think you make it?
Yeah, I'll try.
No, you haven't even discussed with me, and then you said you'll try. Well, if you're really hoping to make it, is there a reason you didn't schedule a meeting with me today or tomorrow?
I thought I can directly discuss.
When?
And today in the
No, this is proposal meeting. People come to rehearse. Yes. So this doesn't work. Right. That's it for now. We are a bit late on time. 你如果没有的话，还是没关系。你再给我开会，你可以准备好一点。反正你刚买没多久，不用急。那你应该慢慢有抓到一些我们这边报告的一些小配合嘛。对，就趁这个机会再改一下。对，我对你的方向跟内容是不会有什么担心，但是简报呈现的地方就是这个是要慢慢摸索，有些小技巧你抓好的话，都概率的包括可以这样做。对，你还没做好对？我等下没问题啊，你要搞到那就不报。All right, so Baosha, you're still online. We think we'll conclude today's meeting, and I know it's getting a bit late because most of you are still surpassed the 10-minute mark. Just a quick reminder that for proposal presentation, unless you are about to do your defense, I'll try to keep your presentation in 10 minutes. And to announce, can you hand me my cell phone? That's right.
Yeah.
Thanks. Right. No, Justin is not here. Pram, would you do the honor of notifying Justin? Because I'm going to announce the next meeting schedule. Right.